There is an example which I have taken to make you understand this. So, here is the example. We have taken an exponential function. We have defined it as y is equal to fx is equal to 2 to the power x. Okay. So, this is the way how the exponential function is defined. So, here the base is 2, which is a constant, and the exponent is x, which is a variable. So, as we defined our exponential function, so this becomes an exponential function. Now, the function given to you is y is equal to 2 to the power x. So, since 2 is greater than 1, obviously this particular function will give us exponential growth. Had it been 0.5 or maybe 0.7 or 0.63, then we would have got exponential decay or exponential depreciation. Now, how to plot? I said to you that every function can be plotted in a graph paper, and every function represents a particular shape when we plot the points in the graph paper. But it was easy to find out the points for the linear functions or maybe for the quadratic functions. How do we find out the points here for x as well as for y when it comes to exponential functions? So, let us have a look at that. As I said, the expression for exponential function is y is equal to 2 to the power x, and now x is the independent variable, y is the dependent variable. So, independent variable always we can assume. So, we can take our own values -2, -1, 0, 1, 2. So, these are the values of the independent variable, and accordingly we can calculate the value of the dependent variable. So, we can write y is equal to 2 to the power x. How to find out the values of x as well as y? Since x is an independent variable, so we can assume the values of x. So, we can take x is equal to -2, -1, 0, 1 and 2 and put here in turn. Accordingly, we can calculate what is the value of y. So, here is a table I have shown. You can create a table like this. This is the function. It is not 2 into x. Again, it is an error. It should be 2 to the power x. So, y is equal to 2 to the power x is the function, and here is the values of x. These are the values of x, and there we will get the values of y, okay, after calculation. So, since the function says 2 to the power x, if I take x is equal to -2, then I will get y is equal to 2 to the power -2. 2 to the power -2 is 1 by 2 to the power 2, which is 1 by 4, which is equal to 0.25. Again, if we take x is equal to -1, then the function will be y is equal to 2 to the power -1, which will give you 1 by 2 to the power 1. In other words, 1 by 2, which is equal to 0.5. If I take x is equal to 0, then we will get y is equal to 2 to the power 0, which will give us the value 1. Anything to the power 0 is 1. If we take x is equal to 1, then y will be 2 to the power 1, which means our value of y axis will be 2, and if we take x is equal to 2, then the value of y will be 4. Now, if we go to the graph and we keep plotting, for x equal to we take -2 and y is 0.25, x is -1, 0.5, then 0 and 1, 1 and 2, 2 and 4. So, we will get a curve which you will find the more x moves towards the positive. Now, this is a graph paper. On the right hand side, we have the positive values of x. On the left hand side, we have the negative values of x. The more we move towards the right hand side of x axis, the y values will be higher. So, the curve will move like this, and the more we come towards the negative values of x, okay, the curve is going to come down and down and down and down. It will not touch the x axis, but it will come very, very close to the x axis. So, that is how a curve is what you are going to get when you plot for exponential growth curve. This is the growth curve. Okay. Since we have taken the variable, the base as 2, which is more than 1. So, this becomes an exponential growth curve. Similarly, by taking in place of 2, if you take 0.5 or you take 0.7 or any value less than 1 and greater than 0, and you try to plot similar type of a curve, you will get a different shape, which will give you exponential decay curve. This is an exponential growth curve. So, I am not showing you the graphical representation of this. This can be taken as a task. You can take this particular function, find out the values are given, go to a graph, take a graph paper, plot the points and join by freehand and find out what is the shape of the graph paper. So that's all about exponential function. Let's do a quick recap. What are the different types of functions we have discussed? Number one, today we have discussed about linear functions, we have discussed about quadratic functions, then we have discussed about polynomial functions. We also talked about the different types of polynomial functions. On the basis of the number of terms, we have got monomial, binomial, trinomial and so on. On the basis of the degree of the polynomials, we have got linear polynomials, quadratic polynomials, cubic polynomials. We also have a constant polynomial or a zero polynomial, okay, and so on and so forth. Then we move to exponential function, where I told you that the main difference between an exponential function and a normal function is that in an exponential function the base is constant and exponents is variable, whereas in a normal function, any other function, when we talk about linear or quadratic or polynomial, there it's the reverse, the base is the variable and the exponents are the constants. That is the main difference. So here also we can find out the values of x and y, which are independent variable and dependent variable, and we can put them in a table. We can go to a graph paper, we can plot these values and join these points with the help of a freehand to find out what is the shape of a curve. So it will be a curve. So if you have the base as greater than 1, then you are going to get exponential growth curves. If you have the value of the base less than 1 but greater than 0, then you are going to get exponential decay curve. We also have made a point, just to keep it in mind, that the base can never take the value 1. Why? Because if the base takes the value 1, then it is going to be a constant function. Okay.